Okay, here we go. Transformations for this new unit. About 20 to 22% of the regents covers this unit. All right, about 20 to 22% of the questions on the regents exam in June come from this unit. So it is a pretty important unit. All right, I want to just see if you could fill in a couple of the blanks from terms we talked about throughout the year so far. A transformation that preserves length and angle measure. We had a name for. Preserves length and angle measure. That was referred to as a rigid motion. All right, rigid motion. If it preserved length and angle measure, it was a rigid motion. When we did talk about dilations, though, all right, when we did talk about dilations, we said that was not a rigid motion because the side lengths changed. But what stayed the same in a dilation? The angle measures. All right, angle measures don't change in a dilation. Couple new vocabulary terms for today. The figure that's about to undergo a transformation. So my original figure I'm talking about, my original figure, I'm always going to refer to that as my pre-image. The figure we start out with before we do any transformations. After you're done doing whatever transformation, after you're done, that I call the image. So we start off with the pre-image, we end up with the image. On number one, let me know if you think that appears to be a rigid motion or not. And if you say yes or no, be able to back yourself up. Does that appear to be a rigid motion or not? 20? No, why not? Okay, side length is different. Yep, nope, side length is different. And remember, in a rigid motion, side length should be preserved. It stays the same. What about the two figures here? Does it look like a rigid motion happened? Here you go, 20 again. Yep, because? Yep, looks like angle measure and side length are the same. Questions on identifying it's a rigid motion. One of the rigid motions we're talking about today is going to be a line reflection. All right, it's going to be a line reflection. What I'd like you to do is just circle this first part that says the line of reflection acts as the perpendicular bisector. All right, that's going to be a huge concept throughout today and tomorrow when we start using our compass for a line reflection, that line of reflection is the perpendicular bisector. How do I know a line reflection is happening? Here is the symbol for line reflection. It is a lowercase print r. A lowercase print r tells me a reflection is occurring. You will also see a subscript with where we're reflecting it over. So for example, I'm just going to put y-axis there. This tells me is a reflection through the y-axis. So you will see the lowercase print r, which tells me it's a reflection. Then you will see something down here below that tells me where to reflect through. All right, you can flip it over here. Let's practice some of the reflections. I'm going to keep the same point through the next 4 examples, 2, -1. So if you want to graph 2, -1, go right ahead and call it point A. I'm going to use that point through the next 4 examples. Okay, for the first example, where am I reflecting it through? According to that notation, 5, where am I reflecting it through? The first reflection. X-axis. So I want everyone right now to look at your point A, and we're going to reflect it through the X-axis. Distance stays the same. How many units is it from A to the X-axis? How many? How many units from A to the X-axis? 1. Distance is going to stay the same, so I'm going to go 1 unit in the other direction from the x-axis. Name that coordinate, please. Don't yell anything out. I'm going to ask somebody. Name that new coordinate for me after I reflected it. What's the new coordinate? 7, 2, 1. Okay, so it's 2, 1, but now here you go. I can't call that point A anymore because it's a brand new point. Will? Nope, nope. Here's how I refer to it. A, but now with this symbol here, that's read A prime, which means I've performed one transformation on it. A prime. All right, next one. Now I'm asking you to go through the y-axis. Count how many units now. Okay, how many units now is A, my original point A, from the y-axis? Here you go, 3. 2 units, so I need everybody to go 2 units opposite the y-axis and name that point now. What's my new coordinate? 13. What's my new coordinate? Here you go, 19. -2, -1. And since that's a new point, I call that A prime. So, any issues reflecting it through the axes before I get to a totally different line? This next line, y equals x. I don't want you to do it on your graph. I'll show you, though. What does that line look like? It goes through the origin and has a slope of 1. Everyone see that line right there? That's y equals x. So I'm asking you to take this and reflect it, flip it through that line. That's a little bit tougher because I can't count anything now. You can't tell me it's 2, 3, 5.5 units away. So how do I figure out where the image is going to be? Ready? Look at the equation. Y is equal to x. Your y coordinate is going to be equal to your old x coordinate. Your x coordinate is going to be equal to your old y coordinate. So think about that. What am I asking you to do to 2, -1? Let me do it one more time. Your new y coordinate is equal to the old x. And your x coordinate's equal to your old y. What am I asking you to do to these 2 coordinates? Flip them. That's it. That's the rule. When you reflect through this line right here, y equals x, all you do is flip the coordinates. So -1, 2. And watch me plot it. -1, 2. There you go. I flipped it over. Okay, makes sense. All right, so y equals x. I'm flipping the coordinates. All right, last one. What line am I asking you to reflect over now? 20? This fourth one here, reflect it through the line. Y equals 2. All right, now, so we do have to do a quick refresh here from algebra last year. Y equals any number is a horizontal line. Y equals any number is a horizontal line going through that number. X equals a number is a vertical line going through that number. So what type of line am I looking at here for y equals 2? Horizontal line going through 2. So it should look something like this. There's y equals 2. Our rules don't change. Count the distance from A to y equals 2 right now. How far apart are they? Count the distance. How far apart are those 2? 15, how far apart are they? 1, 2, 3. So I'm going to go 3 in the opposite direction. 1, 2, 3. And I need somebody to name that new point A prime. What's my new coordinate now? 14? 2, 5. Y equals a number horizontal. X equals a number vertical. I'm going to walk around to every group. Let me see a graph, triangle ABC, then reflect it in the y-axis, and tell me its new points, A prime, B prime, C prime. When you're ready, let me know A prime, B prime, C prime, whenever you are ready. 17, whenever you're ready. Negative 1, 6, yep. And C prime. There we go, nice job. Check them, make sure. Make sure you flipped it through the y-axis and not the x-axis. Questions? All right, last couple of ones here. Before we do anything, do you know where the point, every year I get students who are confused, where 0,5 is? What axis it's on? Is it on the y or the x-axis, 0,5? It's on the y, good. Let's not put it on the x here, so 0,5. There's point x. What type of line is x equals 2? We just talked about it. What type of line is x equals a number? 4? Y equals 2 is right here, last problem, right? And that's a horizontal line. So when I go x equals, that will be a vertical line. Right? Y equals, you go back to that last problem, y equals 2 is a horizontal line. So x equals a number is going to be a vertical line going through 2. Okay, distance doesn't change. How far is point x from that line? 4 again, how far? 2 units, so everybody go 2 units in the opposite direction. Where should x prime be now? Where should x prime be? Here you go, 5.
At
4, 5. All right, so 4, 5. There's x prime. Now everyone take a look. Take x prime, not my original x. Take x prime and go through y equals negative 3. What type of line is y equals negative 3? 19. Horizontal, going through negative 3. So let me graph that real quick. There's y equals negative 3. I did this on purpose. All right, some of you guys are counting and you run out of room to count, but I still need to know the point. How many units is it from x prime to y equals negative 3? How many units? Here you go, 6. 8 units, yeah. 1, 2, 3, 4, 5, 6, 7, 8. But now 1, 2, 3, 4. Unfortunately, I don't have any more for you to count. But you have to go 8 units from negative 3. 8 units down from negative 3. What should be my result? 17? 4, and then that y coordinate should be negative 11. You're going 8 units down from negative 3. Question, I didn't label it though, because I can't label it x prime. I did another transformation. Sean? Double prime, yep. That tells me I just did 2 transformations on x. Yep. Go ahead and graph segment FG right now. And somebody help me out. What's this notation telling me to do to that segment right there? What's that notation? Not, I don't want to know coordinates. Just tell me what it's asking me to do. 9. What am I asked to do here? Where? There's a bunch of things I could reflect it over.
Over the y.
Over.
Another x.
Well, just read the subscript there, Justin. That's it.
Y equals x.
Y equals x. And if you guys remember, that's this line right here. Okay, reflected over that line. What was the rule I showed you guys? The only rule you have to remember. 2, what was my rule? If you're reflecting over the line, y equals x. Your y coordinate is now your old And your X is your old Y, so what am I doing in the coordinates? Flipping them, all right, Will, so what's F prime going to be then? When I graph it, yep, and then G prime will be 3, 4 when I graph it. So 0, 3 for F prime, and 3, 4 right there for G prime. Connecting those, yep. And I'm going to walk around and see you do 4. Now I'm going in a little reverse here. I'll give you the two figures. What line did I reflect it over? Okay, graph those two. What line did I reflect it over? Yep, well, we're going to go because there's one last thing I want to do too. Everyone stay calm. Everyone stay calm. Stay calm. Stay calm. Make sure she doesn't have anything in her mouth. You guys move your desk over that way for me. Just move over for a second. Just move over there. Get it. Stay calm. Health office. Health office. Hi, this is John Carlino in room D238. Can you please contact the health office? I have a student in here that's going into a seizure right now. All right, thank you very much. Room D238. Thank you very much. Bye-bye. Okay, everyone just remain calm. She's fine. Just clear the area.